As said, the project is aligned, and my name is Patrick Ruimerman from B2G. B2G is an SME of around 25, 30 people. We're working from Enschede in the Netherlands. We work on biomass for energy and materials, and we do that in, we are specialized in that, but within that specialism, we are quite wide. We have a combination of R2D, mostly on thermochemical conversion of biomass, and on consultancy and project development. And we think this is a very good combination because we can learn and work with each other to better effect. We have 25 years of track record with lots of projects and lots of spin-off companies. Our work spans the entire value chain from the feedstock assessment towards the supply of products to the end consumer. It's from pre-feasibility to implementation. We know a lot about gamma aspects, sustainability and chain evaluations, legal aspects, knowledge transfer. And we like to work with partners worldwide, in the Netherlands, and especially also in Europe and in European projects. Good. Then the Aligned project. Why did we want to start the Aligned project and what do we try to achieve? The Aligned project was started actually because we did another tender for the European Union, where we looked at biorefineries, what is their outlook, and how can we make sure that there are more biorefineries. And one of that, in that work, one of the aspects was looking at the barriers and the opportunities. And in the interviews with industry, it became apparent that proving environmental sustainability was an issue. It was costly, it is costly. You have to do it on a product level, and you have to do often a full LCA. These LCAs are open to interpretation. There's no level playing field with fossil products. The methods can be sector specific. There is certification and there are labels, but there are lots of them. They are not always effective. And also terminology can be confusing. So we thought, well, we should try to improve that. In the Align project, we try to improve the environmental sustainability in bio-based sectors directly, but also we hope to improve the methodologies so that all these barriers which the industry told us about are lessened or removed. So the rationale of Aligned is that industrial bio-based sectors, and we work with we are focused on 5 sectors. These bio-based sectors, they hold a promise of less pollution, more sustainability, protection of air, water, soil. But this promise should be fulfilled, and the environmental sustainability should be improved, and the proving of that should be easier. So the EU saw that as well. They issued a call to improve that environmental sustainability in these 5 sectors. And we submitted the proposal, and we were one of the 2 projects selected for funding. And the other is our sister project, Calimero, and we like to cooperate to the extent possible. So we work with these 5 industrial sectors: construction, woodworking, pulp and paper, textile, and biochemicals. This time we are focused on the biochemicals, and we work with especially life cycle assessments. We try to improve them. They measure the environmental impacts of material, products, and services in a value chain. So our objectives are to improve, harmonize, and yes, align LCA methodology across these 5 bio-based sectors. We want to demonstrate the power of the methodology to improve the environmental sustainability. And of course, and that's what we're doing now, we want to inform, involve, empower relevant stakeholders so that the methodological uptake of the new things that we try to develop are taken up effectively and efficiently. Well, how do we do that? This is a bit of a complicated picture, but if we start from the left, it becomes more clear. We look at the state of the art. We perform methodological harmonization, and we try to find consensus on what works and what does not work. We develop a methodological framework for a better LCA methodology. We have an iterative analysis and improvement based on 5 case studies. And we have 5 case studies. Each case study is in one sector. And all of that is in a communication and feedback loop with stakeholders. What do we hope to achieve? We hope to achieve aligned and simplified methods to assess the environmental performance. We would like to improve the environmental performance in these 5 industrial processes. And we would like to disseminate data on environmental performance and recommendations to improve this in these bio-based sectors. I'm now saying the same, but in a maybe a little bit more clear diagram. The results that we aim for are shown on the left. Improve the environmental performance in the case study, align the LCA methods, simplify them, recommend to sectors improvements. This should help to strengthen and widen LCA development, to reduce the costs, and to inform policymakers. And of course, that should lead to increased growth of circular bio-based systems so that the environment is better protected. We have a nice partnership of a number of universities, such as Aalborg, University of Antwerp, INSA, and NTNU, and Nari is from NTNU. 5 case study companies, 1 for each sector, and 2 research SMEs, that's B2G and Sustainable Innovations, and 1 sector organization, Centex Bell, and from the logo you might infer that it is the textile industry, and that's correct. For the case study, B2G is on the works on this, the case study for biochemicals, together with the Oleon company, and NTNU was also involved in that. The case study we do with Oleon, that is about improving of looking at part of their product portfolio. They have a certain product which represents about 6% of their activity. They use in that they use vegetable oils, and the vegetable oils they have a certain, of course, environmental impact. And what we want to do is we try to find ways of to see if we can reduce the environmental impact of that product by replacing the vegetable oil feedstock with another one. So the question is, what's the impact now? What will be the impact from an alternative vegetable oil feedstock? And yeah, the applications where Oleon usually works in shampoos, coating, epoxy resins, and encapsulation of electrical devices. Okay. Good. As for the stakeholder consultation and what we are doing here, we want to consult the stakeholders at the beginning of the project and near the end. At the beginning of the project, we want to test the assumptions and the approach. And at the end of the project, we would like to have the results checked and verified with all the stakeholders. These consultation is also related to the sector overview, which Nari made for the biochemicals sector. We want to check if that works. We do that in two ways. We have had an online consultation for which a number of people have given their input, and we will do it with a workshop, this one, so that we have from both these methods some good feedback from the stakeholders. And of course, you are all very warmly invited to come back again near the end of the project in about 2 years, so that you can hear our results and our recommendations. You can find us on various platforms. You can sign up as a stakeholder, also specifically for the biochemical sector. We won't bombard you with a lot of information, but we will target the information, and when we have something useful to say, we will inform you so that you can, with relatively low effort, be informed of what we do. That's the general overview. Does anybody have any questions or comments on this? No? Good. Then I stop sharing, and I would like to give the word to Nari. Oh, I see one hand from Julia Santonin. Hello.
Yes, hello. Thank you for the presentation. I have a very small question. Why did you leave out other sectors such as food or feed production, for example?
Yeah, that's a very good question. In general, if you look at the bioeconomy, that is not those 5 sectors alone, but also food and feed, which are very, very, very big. Yeah, the answer to that is very straightforward. The EU asked specifically work on these 5 sectors. And when the EU asks that in a call, then that is something you do. It's like a Bible. It's thou shalt do this. And yeah, you don't you don't stray from that. That's usually a very non-winning strategy. So we had to stay in these sectors. I think the reason why they did it is that these 5 sectors are very much industrial sectors. Food and feed is very agricultural with a different own dynamic, and this is very much industrial. So it's about machines, manufacturing. So I think they want to have a bit of a focus so that it doesn't get too diluted.
Okay, fair enough.
That's what I can say.
Thank you.
Good. Then I think I can give the word to Nari. Nari worked very hard on the sector overview. And please, Nari, go ahead.
Thank you, Patrick. Hello, everyone. I'm just loading my presentation. Can you just give thumbs up when you see my slide? Okay, thank you. Yeah, so I'll just give a very brief introduction on myself. As Patrick already said, I'm working at NTNU at the Industrial Ecology program. That is one of the 4 programs for the Energy and Process Engineering Department of Norwegian University of Science and Technology. So today we're going to talk about the chemical sector overview. As Patrick also just said, the main goal is to have the life cycle methodology, and in the end of the project you have these recommendations, and then how we are going to do it. So for the case of the chemical sector, we have the case study that will give some insights plus the sector overview to understand how is the state of the art, what are the bio-based materials and applications, environmental impacts and assessments. Then we had the online consultation to understand what is the most important aspects. Then with this workshop here, we want to have your feedback on what is the most important, but why is the most important, and then give feedback up to date. That this way we will verify these results with this feedback, and finally, in 2 years, we're gonna have the recommendations. So going to the chemical sector overview. Currently, Europe Union is the third largest chemical producer in the world, behind only China. But according to some reports from the European Commission, it's predicted that the Europe Union will lose the second position to the US and will go to third. There is a huge gap that is increasing every year on how the production of China and EU is changing. So Germany has the highest turnover for the whole EU. It's a lot of money. It's 546 billion euros. Germany has the highest share, 167 billion, followed by France, that then has a considerably lower, so 77 billion euros. There are around 5.5 million people involved in the sector, in around 30,000 industrial plants or firms. And in terms of production value, it's almost 500 billion euros involved, which is around 280 million tons of chemicals produced annually. For these three aspects, Germany is the first country, followed by France, and Italy is the third one, and then we have some others, the Netherlands, Spain, Switzerland, Belgium, and Austria, that are the lead in the ranking. So why do we look at the chemical sector? So first of all, this sector is very high intensive in energy, and it also has a very high feedstock dependence, mostly of natural gas and electricity. And then in the past couple of years, we had two main events that highlighted how the sector is very dependent on energy and feedstocks. That was the COVID, the pandemic, that blocked all the trades, and also, unfortunately, the Ukrainian war. There's another aspect that is very, very characteristic of the chemical sector. There is a very limited alternative feedstocks. For electricity, we can have wind power, we can have solar power, but for the chemicals, there are not so many alternatives. We have biomass, we have CO2, can be direct air capture, or it can be from other sources, and we have the recycled plastics going back to the streams. Also, the chemical sector is the third largest greenhouse gas emitter in the EU. So last years, it was around 60 million tons of CO2 equivalent emitted per year. But there's good news. The greenhouse gas emissions is already decoupled from the production growth, and it's mostly due to the N2O reduction. So the chemical sector already has a very strong, policy to improve the environmental sustainability. But finally, there's another aspect that has been called attention for the plastic, mainly for the plastic production. That is the end of life. Not all chemicals end up as plastic, but a high share of them do. And there is a huge amount of plastic litter to marine environment. There is a high incineration rates of plastic wastes in Europe, and low recycling rates. Although it's improving, it is still considerably low. So just going to zoom in the plastics, that it's a very hot topic in the moment. So talking about demand by type, the highest share comes for polypropylene, PP, in the graph, followed by polyethylene of high density and medium density, that is the PE, and so on. The application by far is the packaging, with 39% of all the plastic demand in the EU. Then we also have the automotive plastics. And here I will highlight that the plastics demanded for the automotive sector application, they need high glass transition temperature. They need properties that make them harsh and durable. So the global future of the plastics, right now we have very interesting studies. I can put the whole reference in the end. So nowadays, global, not only Europe now, we have around 380 million tons of plastic being produced, which is emitting around 1.8 gigatons of CO2 equivalent. But in the future, around 2050, some studies are estimating that we are going to reach from 4.7 to 6.5 gigatons of CO2 equivalent. And it will vary in these predictions from 1.5 billion tons of plastics to 1.6. So, okay, that's what we are looking at. So how do we minimize these impacts? So we have the sustainability practices. That, as I said, the EU chemical sector is already considerably strong in these practices. There's a lot of things happening on the toxic-free environment to reach climate neutrality, circularity, and end pollution. And I'm going to go through some of these practices. But then we go to this aspect. Can we talk about decarbonization for the chemical sector? We still need the carbon molecule to produce chemicals. So there is a trend to change, instead of talking about decarbonization, to talk about the fossilization. So use renewable carbon sources. And here we have a huge opportunity for biomass. And then, yeah, how do we minimize its impacts? Bio-based feedstock. So the EU already has this bioeconomy strategy and also the bioeconomy action plan since 2018. So let's take a look a bit deeper into the sustainability opportunities. The European Green Deal, from this, a lot of other practices started. We have the Circular Economy Action Plan in place since 2020 around it. We also have the Chemicals Strategy for Sustainability towards a Toxic-Free Environment. So it looks a lot on the toxicity of chemicals and how to reduce it, the impacts for human health and environmental pollution. Then we also have the Safe and Sustainable by Design, that has also a huge opportunity for the improvement of sustainability practices in the sector. More recently, we have three very interesting practices. That is this report called Chemical in Plastics, a technical report from the United Nations Environmental Programme. Then we have the Transition Pathway for the Chemical Industry from 2033. So it was in January launched. And then we have the Global Agreement to End Plastic Pollution that started last year in the General Environmental Assembly. And this year it's starting to be implemented. Okay, so talked about some of the sustainability opportunities. Now looking into the bio-based opportunities. First of all, I want to show this graph that is a combination of two main sources. And as I saw here on the chat, yeah, we can provide the references after. So the white one is the fossil-based chemical, divided here in some of applications like platform chemicals up to man-made fibers. And the green, sadly, is the bio-based share. So in total, currently we have only around 3% of the chemical sector that is bio-based. So we have a huge room to explore it, but that's not only good, only good things. I'll discuss a little bit the challenges in the next slides. Okay, so this only surfactants, they have around half of it that is produced bio-based, but also it's not a huge amount of a huge production amount. So here we have a million tons of each product. So when we're talking about biomass, produced biochemicals from biomass, we are adding value to the biomass. We are supporting sustainable development. We can achieve greenhouse gas mitigation. We can have autonomy and innovation for Europe, considering that, as I said previously, Europe is very dependent on feedstock and energy. We already have considerable knowledge and infrastructure for biofuels production. So in a concept of biorefinery, we can include the chemicals production as well. Currently, most of the feedstocks are sugary, starchy, and oily crops, but there is more attention being given to lignocellulose crops and residues, and also lignin, organic waste, and CO2. Just a general overview of the bio-based chemical, how it can look like. So we have a huge amount of feedstocks that can be used. We have also a high range of processes that some of them are already commercial for biofuel production. Then we have some of the main platforms to then produce chemicals, the pearless oil, syngas, sugar, glycerol, oil, lignin. And then we have a huge list of chemicals. Here are just some that were listed as potential ones by European reports, but of course we have new novel possibilities. So they can come some from sugars, from the lignin. So lignin can be used as a macromolecule, for example. It doesn't need to be depolymerized. And also from glycerol and from oily feedstocks. And then finally, we can have bio-based polymers. Currently, we have PHA, PLA, PE, PET, and TPS, the thermoplastic starches, being used as bio-based polymers. But then, as I said, not only good news, we have a lot of challenges ahead. So first of all, biomass is a limited resource. As we saw before, we have 3% of the chemicals that are bio-based, but do we have all this biomass to replace all of the chemicals, the conventional ones? And European Union already relies on biomass imports for mainly vegetable oils. So most of the bio-based technologies are a very low technological readiness level, the TRL. Bio-based doesn't mean necessarily that is more sustainable. Each process, each technology, each application requires a case-by-case assessment. The life cycle assessment so far is the main used tool to assess the environmental sustainability, but as it was mentioned before, it lacks harmonized methods, specifically for the bio-based sector of chemicals. There's a lack of definition of system boundaries and functional units, because new bio-based products, they can bring in new functionalities that can replace the conventional ones, but can also offer new improvements. How to account for carbon dynamics and biogenic carbon content, we are lacking a harmonization. Also, how to account for plastic pollution and microplastic release for the products. And finally, how to scale up these low technology readiness level technologies. So with this, I wrap up my presentation, and I will give the floor to Marisa for the interactive discussion. And I think I gave some fuel for the discussion. Thank you very much. And any questions, I'm here to answer. Thank you.
Thank you, Nari. Let's see if there are any questions first.
I see Lars Lundqvist has a question.
Yeah. Sorry, I'll unmute myself first. I joined the meeting a little bit late, so I may have missed some of the introductory talk. But I was wondering, you mentioned a few problem statements with respect to LCA in your last slide. But was there a generic problem statement about the shortcomings of LCA with respect to bio-based in the beginning, or not?
So what I can say is that we have some spread initiatives to try to harmonize, but then from Aligned, we are working on some manifestos to have this all summarized in one place, what are all the shortcomings, and we are welcome for feedbacks and ideas and how to improve it.
Because the carbon dynamics and biogenic carbon content there is recommendations from the EU for how to deal with that if you distinguish between short-lived and long-lived products. But I was wondering if you have a connection to the UNEP initiative of doing exactly what you're doing now with respect to how to deal with biogenic carbon.
Sorry, what is the name of the
UNEP, the United Nations
Oh.
Environmental Program?
So far we don't have a formal connection, but throughout the project we intend to have integration with them.
Yeah, I think it would be good to reach out to them so we don't double up work.
Yeah,
we don't harmonize anything.
Yeah,
Mhm.
thank you for this.
Good. Thank you very much.
We will bring this also to the people working especially on the methodologies. And we have a workshop on that, by the way, somewhere in September, especially on the methodology. But we can already bring this in. I think this is very useful to avoid doubling, as what you say.
Yeah. You should reach out to Lorenz Milay-Canals, who's leading the project. And the other question was,
can you say that again, please? Read
Lorenz Milay-Canals. And the other comment was related to the work on plastics pollution and leakage. I mean, I'm sure you're aware of all the work which is already going on, and you may already have established a connection with the Mari LCA project.
Yes, actually, yeah, we have people from industrial ecology that work on this project. To be honest, I'm not sure if we can include already the methods for aligned project, but definitely the discussions are aligned. I really like saying aligned.
Okay, well, that's good. That's good. And I had a third question as well when it related to feedstocks, because you, Patrick, you mentioned in your talk that you were looking into substituting feedstocks, but I was wondering to what extent you're actually accounting for sustainable management of those feedstocks or sustainable cultivation of feedstocks and how to integrate that. I mean, now we talk a lot about improving soil organic carbon and how to account for that on, let's say, a landscape level, a regional level, etc. That's very new. There's not a lot of let's say, agreement on how to deal with it. And I think that's one of the key drivers, probably a higher key driver than the methodology itself. I was wondering to what extent you've given some thought to that subject.
Well, it's good to know that we try to apply the methods developed in our methodology section towards these case studies. And I think this is also a good suggestion with respect to the general methodology, because all the sectors will have to deal with this, the feedstock and also the management practices of the feedstock growing. So I think this is a more general comment for this whole methodology, and we should also take that with us. Yeah. Okay. Then we go to Miss Julia Santolin. You were the second one with your hand up, I believe.
Yes. I was wondering in the last slide with the challenges that you didn't mention energy, because like from my experience, at least, it is a big problem in the bio-based industry that you need a lot of energy to produce these things. And yeah, this has also, of course, a big environmental impact. So I was wondering what you have to say about that.
Sure, this is a point that we will look into. What are the energy demands, and always looking into the trade-offs to see, as I mentioned, the being bio-based doesn't mean that it's really more sustainable. So we have a case-by-case. We should provide a case-by-case study, and then the trade-offs with the energy consumption will be definitely considered. But also at the same time, not specifically for the case study for this bio-based chemical sector here. There's always the possibility of using the waste streams and byproducts from in a biorefinery perspective to provide energy for the process.
Okay.
Yeah. And Lars?
Yeah, sorry, I have a follow-up question on that one, because you mentioned waste streams and side streams. I think they were hitting a really important and subject, because we will have different industry sectors feeding from the same feedstocks, and we're already seeing discrepancies in how certain streams are regarded by different industry sectors. And if anybody of you were involved in the establishment of the PEF methodology, you will know that, for example, the sector or all the industry sectors feeding on the cows had to agree on how to consider all the different outputs from a cow. And in the end, you have to end up with one cow. But if you take all the separate industry recommendations, you'd end up with 1.5 cows or 0.5 cows. And that's a problem. We see this in many areas, like palm oil and other areas, where I guess the agreement will not be able to be established within this project, but it's definitely an elephant in the room that needs to be addressed. And also, in relation to that, the definition of what is a true waste and what is a side stream.
Yeah, that's you touch upon a point which we really like to address. And we know that these 5 sectors, they all use the biomass, and in many cases the same biomass. We want to make sure that that is represented properly. Yeah. Just one short from Konstantina and then Marisa, and then we continue, because otherwise we don't finish on time, and we should. Konstantina, please go first.
Yes, hello. I don't know if you can hear me.
Yes.
So my question was indeed partially answered about the side streams and waste streams for the biomass. I was also wondering if you intend to consider social life cycle assessment, because that might be an interesting approach for the competition for food production and feed production with chemicals and bio-based chemicals production.
Ooh. Anybody in the project team know this?
So we, for the working package 1 of the methodology, we have a framework for socioeconomic assessment, but I'm not completely involved, so I cannot answer with property, but the social aspects are going to be considered for some more of the bio-based sectors. Marisa, if you can complement.
Yes, I think you're right. Yeah.
Yeah, I cannot give more information, but
No.
there are some others from the project that are working with social assessment.
Okay, that I'm looking forward to seeing your results on that. Thank you very much.
You're welcome. Thank you.
Good. Marisa?
Yes, I just wanted to read a couple of questions from the chat, because Antonio in the chat, he cannot talk, but he had a couple of comments. So he asked concerning LCA availability and quality, is it a problem regarding biomass raw materials? Can biodiversity impacts be significant? And if so, how can they be assessed?
Sorry, I'm just reading again.
Yes.
Sure. Yeah, so biodiversity is a huge oh, sorry, I almost wrote something important here. Biodiversity, yes, it's considerable impact. Specifically for aligned, we are not looking so much into details, but I can say that it's hotspot also in European Union is taking more attention to it. So in some of those sustainability practices, I mentioned just a few, but I took a deep look in some of them. Biodiversity is gaining more attention. So then it's not only greenhouse gas mitigation that we have to take a look into, but also the other environmental impacts, and biodiversity is one of them.
Okay. And then he also asked concerning feedstocks, how biomass compare with CCU, in particular with carbon captured from air or other punctual sources, combined with the green hydrogen and using renewable energy.
I don't know. We would need the as a case-by-case assessment, making this comparison, which would be very nice. So a nice study that can come up. But what I can tell is that Aligned is not going to look into CCU and green hydrogen. So we would be maybe for a future assessment and partnerships to have this very interesting combination of for a benchmark. But unfortunately, we are not going to consider them.
Yeah, well, if I may speculate a bit, I think that CCU or carbon capture can be a very good carbon source, and that would be very nice. And it can coexist in theory if it can be done economically and efficiently. Can coexist very much with bio-based, with the bioeconomy and the bio-based economy. And we will have biomass because we use it, we eat it, we use it for construction, etc. And we will have residues. We will have to do something about it. So the bioeconomy won't go away. But having an additional carbon source, I think this would be great. And yeah, we hope, of course, that technological development will ensure that this will also be really unlocked on a sufficient scale. It's not yet there, but yeah, we look forward, of course, to large-scale implementation. There are some more questions, but I propose that we continue because otherwise we don't get to the end. I would like to give the word to Marissa for the interactive discussion. Please, Marissa, explain how you should do it.
Yes.
How we should.
Okay. Do you see my screen?
Yes.
Okay. Well, thank you, Nadi, for that great presentation. So we were already having a little discussion here, but we would like to get your opinion on some of these topics more specifically. My name is Marisa Groenestegen and I also work at BTG. And we would like to have this interactive discussion through an online tool called AHA Slides, which is similar to Mentimeter. So you can join through a website called AHA Slides. So either scan the QR code or you can go to this website shown on the screen. So you can scan the QR code and join the AHA Slides where you can answer questions and submit your answers, or you type in AHA Slides on your phone and go to the website and fill in Biochemic. And then you will get to the same website as through the QR code, where you can give your answers to some of our questions. And be aware that sometimes when we move to a different question, that you will have to click on the top to go to slide. Otherwise, you will be stuck on the previous question. So let's try it out. Please join the AHA Slides. The QR code will still be shown on the screen. And please let me know if you have any troubles with joining, but we can have a couple of trial questions first so you can all get the hang of the program. So let me ask you, what is your field of occupation? I see that a lot of you have already joined, which is great. Already 14 answers. 15. Is there anyone having any issues with the program? Okay, and otherwise the QR code will still be shown on the screen for the next question as well. Lots of people are working in the research, which is great. Some suppliers, manufacturers, and one consultant. Okay, I think we can move on to the second trial question. So this is in what country are you located? So this question is in the form of a word cloud. So you will have to type your answer and submit this answer. So quite some people from Germany, the Netherlands, Belgium, Portugal, the US, Spain, Norway, France, Switzerland, Greece. So a nice mix of people, I would say. Okay, that is 16 out of the 16 people who have joined. Again, if you have any questions, please let us know, or you can tell my colleague in the chat. But I think we can move on to the real questions. So our first question to you is, what are, in your view, the most important environmental problems of the chemical sector as a whole? So we would like you to pick the 3 most important environmental problems in your opinion. So some of the options are human toxicity, ecological toxicity, the release of microplastics, end-of-life waste, that they are not biodegradable, land use, GHG emissions, resource availability, the effect on climate change, the dependence on fossil feedstocks, the dependence on other countries that use a fossil energy mix, and if there are any other environmental problems that we missed, choose the other option, and we would love it if you could elaborate on why you think something else is important. So should we have a look at the, as my colleague told you before, we also had an online consultation in which we asked a similar question. So in the meanwhile, while you're still choosing your answers, let me give you some of the responses from this consultation. So the people on here, they also voted for greenhouse gas emissions as the most important environmental problem. So they were asked to rate the importance of these environmental problems to the chemical sector. And they chose greenhouse gas emissions, followed by the effect on climate change, end-of-life waste, ecological toxicity, and the dependence on countries with a fossil energy mix as the most important environmental problems, which I think is pretty comparable to at least GHG emissions. It's pretty comparable to the answers of the consultations, as well as the importance of ecological toxicity.
It's remarkable that the microplastics in the forum here, it's considered really as an issue, but in the consultation, it's very, very low.
Yeah, it was almost the lowest.
Yeah.
Yeah.
Yeah, I would say I'm not an expert on this, but I would say that it is a problem. But is anybody wants to comment on this? Or?
Yeah, I do agree, and I think it's a big problem because it's very unknown, the effects, right? I think this is still coming to the surface, And I think it's might be way worse than we think even, but every time I see some new article about it that they find microplastics, I don't know, in the placenta or things like this, it's very related in the end also with human toxicity. So I think some of these points, they really overlap. But yeah, I do see this as a very big problem. Also because I think our analytics sometimes are limited, right? So I mean, even in terms of ocean pollution and so on, it's difficult for us to get a clear picture of what's going on.
Lars?
Yeah, I've been trying to get a clear picture on this ever since Jambek came out with her